The 3D modeling component of our system allows PaperCraft-based modeling with developable surfaces. We have seamlessly merged this with our fabrication tool, making PaperCraft3D an all-in-one system for casual 3D modeling of developable surfaces and subsequent 3D fabrication. Traditional 3D modeling systems are desktop-based and limited to single-input interfaces. Though powerful, they're very difficult to learn for a person with little or no prior modeling experience. As an alternative, we present PaperCraft3D, a new system inspired by papercrafting and designed from the ground up for a multi-touch interface, specifically an iPad. Modeling in our system involves simple, intuitive operations that are relatable to modeling with physical paper and allow users to easily create a wide range of models. For example, using a 2-finger pinch gesture, a user can repeatedly fold a flat piece of paper or face of the model while simultaneously adjusting the angle of the fold. A different folding operation allows a user to pinch a section of the paper upwards, with the position of the user's fingers controlling the orientation and height of the created peak. In addition, we provide tools for adding natural-looking curvature to a model. For example, a user can bend the corner of a face with real-time control over the desired amount of curvature and its orientation. We let users form new faces by extending or unrolling paper from any boundary edge. Conversely, users can cut a model along any crease or fold. A 3-finger pinch extends along each boundary edge of a face. The angles of the folds can then be adjusted simultaneously. Pinching over 2 disconnected edges forms a new face that bridges them. Thickness can easily be added to a model with a 4-finger pinch. Here we show a short sped-up clip of a user designing an indoor scene with several desk lamps. The user bends, cuts, and extends 3 sheets of paper to create the components of the lamp. These components are then pinned together in the assembly mode of the system. After coloring and duplicating the lamp, the 2 copies are pinned to the table in the scene. Finally, we present a selection of scenes designed by independent modelers who have learned to use our system. The first one is a PaperCraft-like jungle scene with a collection of animals surrounded by plants and trees. The modeling operations in PaperCraft3D allowed the user to create this scene with ease. This example shows a more traditional interior scene showcasing a manuscript lying on a podium. Natural yet non-trivial curved surfaces like the pages of the book or the windowsill can be easily modeled in our system. The scene shown here is an interior of a library. Both the curvature of the lounge chair and the lamps are straightforward to create in our system, even for novice users. Our final example shows a stage set inspired by the work of designer David Hockney. The paper modeling operations of our system are very good at handling less volumetric types of models, like the ones present in this scene. The benefits of 3D scene fabrication are numerous. For casual 3D modelers in particular, producing a personally designed 3D model is both entertaining and fulfilling, and provides them with a greater sense of authorship. While 3D modeling developable surfaces is popular, fabricating a 3D scene like the one shown here still poses various difficulties for existing fabrication methods. There are issues with reproducing the size of a larger scene while maintaining its spatial layout, as well as fabricating unclosed meshes and accurately reproducing textures. 3D printing in particular has seen a surge in popularity, but still has high costs associated with it and can be challenging for casual modelers. As seen in this example, it can have notable limitations as far as accuracy, resolution, and lack of texture. Here we present PaperCraft3D, a fully integrated paper-based 3D modeling and fabrication system for developable surfaces. PaperCraft3D provides an easy-to-use method for creating fully textured, stable fabrications of user-modeled scenes. Our method automatically prepares 3D scenes for fabrication, adding assembly guides and associated fiducial markers for accurate assembly. In order to preserve the spatial relations between scene components, a small amount of supporting structures are also added. The fully textured mesh is then unfolded and segmented and printed onto sheets of paper. With the automatically prepared guides and fiducials, the assembly part of the scene is a very straightforward and sequential process. We ensure consistency between the virtual and fabricated models by automatically adding several types of supporting structures to the fabricated scene. In addition to already existing supports, edges that are in contact with the ground can form an extended support. Regular supports come in the form of triangular prisms extending to the ground plane. Separate supports can also be added to maintain the shape of curved objects. To adequately position supports, we've incorporated several engineering principles into our fabrication method. These include properties of static equilibrium to make sure the centroid and base of each model are well aligned, Bernoulli beam theory to minimize a paper model's deformities due to its material elasticity, and column buckling to ensure that added supports can bear the weight of the model above them. The supports are added using an optimization algorithm that factors in these principles, along with several aesthetic parameters to minimize the visibility of the supports. Once a scene is prepared for fabrication, unfolded, and printed out, fiducials and folding guides help the user intuitively assemble the scene. Cutting, folding, and gluing is all it takes to go from printed sheets to a fully textured 3D fabrication that is faithful to the original 3D scene. Here we showed the jungle scene from the first part of the video fully fabricated using our method. The features of the 3D model virtual scene on the left are faithfully reproduced in the fabricated scene on the right. Here we show the David Hockney-inspired stage set and compare the 3D modeled scene on the left to its PaperCraft3D fabrication on the right.